Good afternoon to all students. Today in this practical session, we are going to have a look on experiment number 3, that is to study the latching and unlatching of a motor by using the DOL starter. You need to go to the virtual labs from your browser. Just type VLab COEP Google, then you can go to the first link and just go to the PLC lab. How to use the lab, that video I have uploaded in the experiment number 2. You can go and check that. So it shows welcome to the programming control logic controller lab. Okay, so go to the list of, then go to the third one, that is implementation of DOL starter, diet online starter. So aim is to develop a ladder diagram or program for direct online starter of a motor. So objectives are to understand working of DOL starter and then develop a ladder program for starting an electric motor using DOL starter. So we can go to the pre-test. You can give the answers. For example, an electric motor converts electrical energy into mechanical energy. Okay. Then dash is a unit to measure the output power of an electric motor. HP, horsepower. The electric motor consists of magnet. The motor armature acts as a a rotor. So for operation of the dash application, electric motor is not required. So water filter, refrigerator, mixer. So water filter operation, electric motor is not required. Submit it. You can see here 5 out of 5. Okay. So go back again. Now go to theory. So how DOL starter works. Okay, this is what control circuit for DOL starter. This is our phase and this is neutral. Okay. Then this is fuse. This is start push button. This is stop push button. This is your relay or contactor contact to the motor, and this is your relay. Okay, actual. So this is push button for this relay. Okay. So DOL direct online motor starter contains fuse and overload relay, that is OLR. Okay. So the method of starting electric motor is by using DOL starter across the line starter. Okay. So in this method, full line voltage is applied to the motor terminals, and this is the simplest type of motor starting method. This is the wiring diagram. So the starter can be contain momentary contact or maintained contact push buttons. Okay. So the example considered here is momentary contact push buttons. This is stop start. Okay. So for starting purpose, normally open push button is preferred, whereas normally close push button is used to stop the motor. Okay, we can use that circuit. For starting, normally open push button. These are just push button. Okay. So for start, normally open push button. For stop, normally close push button we can use. And the excessive supply voltage drop causing high inrush currents is the criteria to limit DOL starter. So convey motors, water pumps are the different applications where DOL starters are used. Okay, and high inrush current is the term which is a limitation to that of DL starter. So now procedure we are going to see. So the problem statement is given as to start a motor using DL starter. So diagram is given. This is output, this is input. Okay, in the first rung we can use this start and stop buttons. In the second run you can, in the first rung itself and the second rung also, you can use at the output side, you can use the motors. So list of input and output devices are, so first inputs we require one push button to start the motor, that is PB1, and one push button PB2 to stop the motor. Okay, that could be either NO or NC. Output is the output coil, which is motor M1. So now sequence of events. So when start push button is pressed, motor has to start. Okay, and if this push button 1 or start is released and this is not pressed, motor should remain on. Okay, if it is released and this is not pressed, this should remain on. And then when this push button to stop is pressed, motor has to stop. And if the stop push button is released, means it is turned off, and the start is not pressed, the motor should remain off. This is what the event, this is what how we are going to make the simulation. Okay, so this is what your ladder diagram. So there are two different methods to perform the same operation. Okay, this is quite complicated, this is quite simple. Okay, so in this we are not going to use latch or unlatch command. Here you are going to use latch or unlatch command. Okay, so here you can see that two push buttons, okay, normally open, then one push button normally close, then this is output coil. In the second rung, only one normally open push button and the output coil. Okay, so as the momentary contact push buttons are used here, the condition of this PB1 is maintained through the contact of coil C1. Okay, this contact is called as latching contact. So latching here is done by an external or extra normally open contact. The same sequence can be done in a very simple way. We can just use two extra functions, which is latch and unlatch. Okay, so this is your normally open push button PB1, this is PB2, and this is M1 M1. Okay, simple motor, only one motor, but latching motor and unlatch motor. Okay, two different commands or diagrams. So when this is on and this is off, this should on, and when this is off, this is also off, this should remain on. After that, when we use this, when we turn on this should be off, and when both are off, this motor should be off. This is what we are going to study. So we are going to go to the simulation. Click on the simulator. So I am using my mobile hotspot, so it might be take some 3 to 4 seconds delay, so sorry for that. Just click here to simulator, then the simulator will open. You can see here, this is for DOL starter. Okay, simulation. Here first of all you have to add rung number 1. Okay, and another rung number 2, because this is the procedure. Okay, here two normally open push buttons and motor latching, motor unlatch, two rungs. Okay, so just add, click on this, put it here, put it here. Okay, click on the mouse to release. Okay, now right click on this tag. Okay, just type. Now just tag this as start, then submit it. Now go to this, tag this as stop. Okay, now then at the output we need to use this coil or this latch and unlatch. So when we use this coil, you can put here, you can put it here. Okay. Now if I tag it with name as motor for first one, for the second one I have to give a different tag name. You cannot use the same tag name for both the outputs. If I give the same tag name, it shows invalid. Okay, because same label for output is not allowed. So for that purpose, just delete this coil. Okay, we are going to develop this logic. Okay, instead of going to this logic, this is complicated. We are going to just use motor latch and motor unlatch. Okay, now just click on latch, then click over here, click on unlatch, click over here. Okay, now just click on mouse, it will remain stable, and click on configure. Now you can write it mode over here. You can also change this configure. Okay, motor. Now this is what our ladder diagram looks like for a DOL starter of a motor. Okay, now just compile it, then run it. Okay, after running, this gets turned into green, which indicates this rung, both the rungs are activated. Now if you toggle this start, you can see both, means motor will turn on. Okay, as they were told here. So sequence of events in which when start button is pressed, motor has to start. When I press this, motor gets started. Then when I release this start button, okay, PB1, and this is not even pressed, okay, the motor should remain on. I'll show it. When I toggle this, it will remain off. So motor will remain on in that condition, okay, because of latching. So when we need to stop the motor, we have to press this PB2, that is stop button. So when I push this or toggle this, the motor will stop. Okay, again if I toggle this, make it 0, the motor should remain still off. So if I start this, the motor will start. Okay, this is how DL starter works. Okay, by using the motor latch and motor unlatch. Okay, so the motor will stop only when this push button is turned on, because this is unlatching of motor. Okay, up to then it will remain on. Okay, this is used to start, this is used to stop. Okay, now you have to remember few points. So unlike the previous case, in the logic gates operation, we have used normally close contact for that is normally close contact push button here, okay, to turn it off in NOT case and NAND case, okay. So in this case, latching and latching, you have to use normally open contact, and the reason is I will show you. If suppose you go to development mode, if I delete this, okay, if I use this normally close contact here, then I will tag this as stop. So it is normally closed, that is 1 at the start, okay. So if I use normally close contact, the motor will never switch off. I'll show you how. So now just compile it, then run it. Okay, now if you toggle this, if you toggle this, the motor will not start because if you start this, the latching will turn on, but this is on by the start because it is normally closed contact. So unlatching of motor is started at the start. So motor will switch off for most of the time. If we this off, make it 0, you can see a stop is 0, then motor will turn on, okay. So if you toggle this, motor will turn off, okay. So by using this contact, the motor will not start, okay, it will not turn on at the start. You need to turn this off for that, okay. So the toggle, after toggling this start button, you can see the motor does not switch on, and the reason is once normally closed contact is on, the latch will get switch on, but simultaneously as you are executing rung 1 also, you are unlatching this output, and this output will never get switch on, and that's the reason there is slight change in this diagram, and you have to take normally open contact here. So go to development mode again, use delete, take your normally open contact, place it here, click on mouse to remain stable, tag it, okay, name as stop here. Now compile it, then run it, okay. After, now you can toggle this, you can see motor will start because this is 0 at the start, motor is not unlatched, so motor is only latching. If you toggle this, make it 0, the motor is remained on, okay, still it is remain on. So when you will to stop this motor, you have to push the stop button, toggle this, you can see, okay. After pushing stop button off, making it 0, the motor is in the off state, okay. So now you can repeat the procedure. So we have achieved this sequence of events by using this ladder diagram, okay. This is what your simulation is about. You can go to post state test, you can give the answers if you want. It's taking a while because I'm using my mobile hotspot for this. So DOL starter stands for direct online starter. So DOL motor starter contains dash for rotation purpose. Okay, overrode relay. Okay. For starting of an electric motor, dash is preferred. Normally open. Okay, push button. Dash is the criteria to limit inrush, high inrush current. In which of the following applications DOL starter can be used? Both A and B. Okay, then submit it. So you will get to know the results. One of my answer is wrong. You can use the solution. First C. Okay, diet online starter. I, I thought I thought this is a diet. It is digital. Now you can see. Okay, so you can run this in your PC or laptop with internet connection, and also in mobile you have to use Google Chrome and then change to the desktop version. uh, just there is a switch which you have to click, then it will change into the desktop version, and then you can browse this virtual lab. Okay, if you have doubts you can ask me. Do watch this video to the end, and if you have any other queries you can also ask me regarding the program. Okay, so till then take care and have a nice day.